and we are going to be starting with concept 1 notes on the structure of the atom. Now, a lot of this unit is going to be about the periodic table, but in order to understand the periodic table, we have to understand atomic structure because both of these go hand in hand. So that's what we're going to start with. So first, let's talk about what an atom is. An atom is the smallest particle of an element that still has the properties of that element. Remember from our last unit that an element is the simplest form of matter. I think a way to understand this best is through an example. So think about a compound like water, which is H2O. It is made of 2 atoms of the element hydrogen and 1 atom of the element oxygen. So that's kind of how we use this language of atom and element together. Now, I don't normally go talk about a lot of history with y'all just for the sake of time, but I think understanding how we came about the discovery of atomic structure is a really important thing to know and to really appreciate in terms of how scientific discoveries build and kind of correct each other over time. And so we're going to talk through it, and you'll be expected to know it for my assessments. So, in 400 BC, Democritus was the first to name the atom. And atomus means indivisible in Greek. And he named it the atom because he thought that there was nothing smaller than it, that it couldn't be divided up, which we know now today isn't true. But at the time, this was the understanding he was using. In 1803, so a good bit later, John Dalton came up with a solid sphere model. So he thought the atom was a solid sphere and it couldn't get any smaller. Now, this is not true, but the other thing he thought is actually true. He said elements are made of atoms that all have the same mass, and compounds are atoms of different elements combined, which is like what we were talking about on the previous slide. Now, in 1869, Dmitri Mendeleev was the first to kind of assemble a periodic table of elements, and it looked a good bit different from what we have today, because he organized it by atomic mass. And I'll introduce you to someone in a minute that came up with more of the organization that we have today on the table. Now, in 1904, J.J. Thomson came up with a plum pudding model, and it was named this because it was a popular dessert at the time. It was basically a pudding with chunks of plum in it. If it was going to be, if he had discovered this in 2017, it'd probably be J.J. Thompson's chocolate chip cookie model, because it's the same idea. But first, he was the first one to say, okay, the atom is actually divisible, and it's actually a positively charged sphere, because there's positive and negative parts, but the sphere is positive and there's negative pieces embedded throughout. So that would be like the chunks of negative plum in the positive pudding, or negative chocolate chips in the middle of a positive cookie. That kind of thing. And I'll explain these arrows in just a minute. So, who came next is 1911, and this is Ernest Rutherford with something called the nuclear model. And he figured this out using a gold foil experiment. So basically, he shot a beam of alpha particles, okay, into the atom. And what he saw was they were deflected around the center. Now, if this had been done with JJ's plum pudding model, if his model would have been true, then they would just go straight through. Those alpha beams would go straight through, but that's not actually what happened. When he shot those alpha particles through, the beams were deflected off of the center, as you can see in this picture. So what he deduced from that was there was a dense center to the atom, and it had most of the mass of the atom in it, and he called this the nucleus, and that's where the positively charged particles were. And then surrounding the nucleus was a space that had less mass to it, but it had the negatively charged particles surrounding it. So this is all very true things. We just know more detail about the structure now. So, 1913, Henry Moseley, he was the one that discovered the number of protons in an element is unique to that element. And so that's what the atomic number is. So like hydrogen has 1 proton, so its atomic number is 1. Helium has 2 protons, so its atomic number is 2. And so he arranged the periodic table based on atomic numbers or number of protons. And that is how we arrange the periodic table today. Also in 1913 was Niels Bohr, and he came up with the Bohr model. And what this says is that electrons are negative particles that travel in fixed orbits, think of like the planets, around the positively charged nucleus. And the nucleus is made of positive protons and neutral neutrons. So it'd be like this top picture. We've got positive particles, we have neutral particles in the center, and then these negative electrons surrounding it, and they move in these circular orbits. So he was right about the nucleus with the positive and the neutral, and then the negatives, the electrons being around, but not about the fixed orbits. Our correct and current understanding as of now is from 1926, and this was Schrodinger and Heisenberg, and they came up with the electron cloud model, which says that the nucleus is surrounded by a cloud of electrons, and that the cloud is subdivided into shells or energy levels that electrons are in, but they don't travel in fixed orbits. They actually move kind of crazily within their shells, and they can actually jump shells at some points. And in class, there's a really great animation that I think shows what the electron cloud model looks like. Now, we can't really draw the electron cloud model unless you are able to draw animations on your paper, which is pretty awesome. So whenever we draw the structure of an atom, we are actually going to draw a Bohr model. We're going to draw the electrons almost as if it was a freeze frame picture, and we're catching it at a split second and taking a picture of the electrons kind of frozen in an orbit, where in reality it's an animated structure. So just to summarize, because I do think I don't want you to be confused by kind of, okay, so who came up with what's right and who came up with what's wrong. Here is the true summary of the atomic structure as we know of today. There are two parts to the atom. One of those is the nucleus. It is the dense center in the atom, as we see in this picture with the red and blue center. It is made of two parts, protons and neutrons. It has an overall positive charge because of those protons. And it's very dense. Because of it's so dense, that's where the mass of the atom is located. It's all of the mass is pretty much in the center. The other part of the atom is the electron cloud, and it is a space surrounding the nucleus. It is broken down into regions of space called shells or energy levels, so those are interchangeable. The electrons and shells that are furthest from the nucleus have the most energy, and the ones that are in the most outer shell are called valence electrons, and those are going to be so important in future units to understand. Because the electron cloud is made of electrons, it has an overall negative charge, and we say it's where the volume of the atom is located, because as you can see in the picture, the cloud and the shells, that's what's taking up the most space in the picture. All right, let's talk a little bit more about those subatomic particles, the three particles that make up an atom. So you have your protons. To abbreviate proton, if you ever want to use an abbreviation, it's a lowercase p with a positive sign. And that's because it is the positive particle that's located in the nucleus, like so. The neutron is abbreviated N0 because it is a neutral particle. It is not positive or negative. It is also in the nucleus with the protons. The protons and neutrons are made of quarks, which are our smallest known particles at this time. So you can actually even further subdivide protons and neutrons into quarks, which is kind of crazy how much smaller we can really get. And if we could even maybe get smaller than that one day in terms of our understanding. And last, there are electrons, which is abbreviated E negative because they are negative particles and they're outside the nucleus in the electron cloud, as pictured here. All right, last but not least, I want to talk about what is holding the atom together, and it's held together by some forces. There are three forces that hold it together. First, there's an attractive force between the positive nucleus and the negative electron cloud. Why does this make sense? Well, we've learned in prior units that opposite electrical charges attract. So that makes sense that those would be attracted to each other. This is what's really holding the atom together, is this attractive force. Now, what gives the atom some of its shape is the repulsive force between the negative electrons. Remember, like charges repel. So electrons want to be as far apart from each other as possible because they have the same charge. And so this gives the electron cloud a lot of volume as the electrons try not to be near each other and try to spread themselves out. Now, what I think is so interesting about the atom and what gives it insane amounts of energy is the repulsive force between the positive protons in the nucleus. Because, again, remember, like charges repel. So those positive protons do not want to be near each other, and yet so they want to be as far apart as possible, but they're packed in really tightly in that nucleus. And so what that means is that there's an insane amount of energy that holds the nucleus together because of this. And that's when we release that energy, that's how we create atomic bombs, which hopefully we'll have time to talk about at the end of this year. So that is your overview of the structure of the atom.